So, let's go. You think you know how big space is? You don't. And the worst part isn't the size. It's that we're going to start somewhere close, somewhere familiar. And by the end of this video, familiar won't mean anything anymore. 10 distances, real numbers. And by number 4, the rules change. Number 1, the moon. 384,000 kilometers away. That sounds far. It isn't. Not really. Not compared to what's coming. Here's the thing about the moon. It's close enough that you could drive there. 100 kilometers an hour, no stops, no traffic, straight up. You'd arrive in about 160 days. A commercial jet gets you there in roughly 18 days. That's a long flight, but it's a flight you can picture. During the Apollo missions, astronauts talking to mission control had a 2.5-second pause between question and answer. You can hear it in the recordings. That tiny silence is the sound of light making a round trip to the moon and back. That's how close it is. Close enough that the delay is awkward, not catastrophic. Here's something almost nobody knows. Right now, at this exact moment, there are mirrors sitting on the lunar surface, left there by Apollo astronauts. Scientists still bounce lasers off them. The light leaves Earth, hits the moon, comes back, and the whole trip takes about 2.5 seconds. The moon is so close we use it for precision experiments from the ground. And here's the one that breaks people. Take all 7 other planets in our solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, line them up side by side. They fit between Earth and the moon. All of them, with room to spare. The moon is so close that the rest of the solar system fits between us and it. So if that's distance 1, what exactly are you about to walk into? Number 2, the sun. 149 million kilometers. The sun is about 400 times farther away than the moon. Light takes 8 minutes and 20 seconds to get here from the surface. That sounds like a lot until you realize that 8 minutes is how long it takes you to make a cup of coffee. The sun is 1 cup of coffee away at the speed of light, but here's what that actually means. If the sun disappeared right now, just vanished, gone, you would not know for 8 minutes. You would stand outside in normal daylight, feeling the warmth, seeing the sky, completely unaware that the star powering all of it had ceased to exist. And then the light would stop, and it would be dark, and it would already be too late to do anything about it. Gravity, by the way, would also stop reaching us at that same moment. 8 minutes of blissful ignorance before the planet goes dark and cold and silent. Here's the counterintuitive one. Earth is actually closest to the sun in January. Northern Hemisphere winter. Seasons have nothing to do with distance. They're caused by the tilt of the planet. You are closer to the sun in January than in July, and yet it's cold, because proximity to a star matters far less than which way you're pointing. The fastest object humanity has ever built, the Parker Solar Probe, hits a peak speed of just under 700,000 kilometers per hour when it swings close to the sun. At that speed, it would take about 9 days to reach the sun from Earth. 9 days at the fastest speed we have ever achieved. Now remember that number, because we're about to need it. Number 3, the edge of the solar system. 100,000 astronomical units, about 1.5 light years. Most people, if you ask them where the solar system ends, say Pluto. Pluto is 40 astronomical units from the sun. That's 1 astronomical unit being the Earth-Sun distance, so Pluto is 40 times farther from the sun than we are. That's not the edge. The solar wind, the constant stream of charged particles blasting out from the sun, eventually runs out of momentum. It hits a boundary called the heliopause, where interstellar space pushes back and wins. That boundary sits at roughly 120 astronomical units. Voyager 1 crossed it in August 2012 and became the first human-made object to enter interstellar space. That's still not the edge. The actual gravitational reach of the sun extends to the Oort cloud, a vast distant shell of icy bodies beginning around 2,000 astronomical units, out and stretching all the way to 100,000. Comets that take millions of years to complete one orbit around the sun come from there. Long, slow loops from the absolute frontier of the solar system. The Oort cloud has never been directly observed, not by Hubble, not by the James Webb Telescope, not by anything. Its existence is inferred entirely from the paths comets take when they fall inward. We are reasoning backward from the debris to the source. At 100,000 astronomical units, the sun looks like a star, just a bright one. solar panels are useless. The warmth is gone. You are still technically inside our solar system, and it is already completely alien. Voyager 1, the farthest thing we have ever launched, has been traveling for nearly 50 years. It has barely reached the inner edge of this territory. Something is off about the math, and you're about to feel it. Number 4, Voyager 1, 23.5 light hours, about 25 billion kilometers. This one is different. This isn't a destination. This is a mirror. Voyager 1 launched on September 5th, 1977. It was designed for a 5-year mission to Jupiter and Saturn. It is now 47 years old. It is the farthest human-made object in existence. And in late 2026, it will cross a milestone nobody in 1977 could have fully pictured. It will be so far away that a radio signal from Earth, traveling at the speed of light, will take a full 24 hours to reach it. A full day just for the message to arrive. Another full day to get the answer back. The spacecraft transmits data at 160 bits per second. That's slower than a 1980s fax machine. NASA has to point massive 70-meter antenna dishes, some of the largest in the world, just to pull in a signal that arrives at about 20 billionths of a billionth of a watt. It takes an array of antennas working together to hear it at all. Voyager 1 has roughly 3 million times less memory than a modern smartphone. It runs on about 250 watts of power, less than a few light bulbs. And yet, it has been operating continuously for longer than most of the people watching this have been alive. On board is the Golden Record, a gold-plated copper disc containing sounds of earth, surf, wind, thunder, music from dozens of cultures, greetings in 55 languages, 116 images, a kind of message in a bottle, except the bottle is drifting into the void between stars at 17 kilometers per second and will never be retrieved. Here is the number that ends the first half of this video. Voyager 1, at its current speed, would take approximately 73,000 years to reach Proxima Centauri, the nearest star. And it's not even pointed in that direction. Everything before this section, the moon, the sun, the entire solar system, is close enough that we have visited it, aimed something at it, or at least have a plan. Everything after this section is somewhere we have never sent anything, and likely never will. Not in any of our lifetimes, not in most of human history's lifetimes. The rules just changed. Number 5, Proxima Centauri. 4.24 light years. 40 trillion kilometers. 4 light years sounds like a small number until you realize that light travels 300,000 kilometers every single second. 4 light years means a photon, moving at the maximum speed the universe allows, takes 4 years and 3 months to cover that distance. That photon, traveling without rest, without slowing, at the universal speed limit, takes 4 years. You, traveling at the speed of the Parker Solar Probe, the fastest object humanity has ever built, would take approximately 6,300 years. Proxima Centauri is a red dwarf, small, dim, and furious. It has a planet, Proxima b, sitting right in the so-called habitable zone, the distance from a star where liquid water could theoretically exist on a surface. Scientists confirmed it in 2016. The internet lost its mind a little. Our nearest neighbor has a potentially habitable planet. Then they looked closer. Proxima erupts. Multiple times a day, it releases solar flares. Not like the ones our sun produces. Much worse. In 2019, it unleashed the largest stellar flare ever recorded in the Milky Way, briefly shining 14,000 times brighter than normal in ultraviolet light. Any planet in that system is getting blasted by radiation that would strip away an atmosphere over millions of years. Whether Proxima b has any air left is genuinely unknown. There is a project, Breakthrough Starshot, that wants to fire tiny laser-propelled probes at 20% of the speed of light toward Alpha Centauri. If it works, travel time would be about 20 years, then 4 more years for the signal to come back. Best case scenario, you launch today, and in 24 years, you know what's there. That project is real. The lasers do not exist yet. Proxima Centauri is the nearest star, the closest thing to us in the entire galaxy, and it is so far away that our fastest spacecraft would take 6 millennia. Our best theoretical future technology takes 24 years just to send a probe and hear back, and the light arriving from it right now left in early 2022. You haven't seen Proxima as it is. You've seen Proxima as it was. Number 6. The Milky Way, 87,400 light-years across. Take the distance to Proxima Centauri, 4 light-years, the number that already broke the scale. Now multiply it by 20,000, that's the diameter of the galaxy you live in. The Milky Way is a barred spiral, a flat disk of stars, gas, and dust about 1,000 light-years thick at the arms and 87,000 light-years wide. It contains somewhere between 100 and 400 billion stars. Scientists genuinely aren't sure of the number within a factor of 4. There could be 200 billion stars in here. There could be 400 billion. Or, we do not know, and the uncertainty is larger than the number of stars in most galaxies. The sun sits about 26,000 light-years from the center. Not close, not at the edge, just out in the suburbs. We orbit the galactic core at around 800,000 kilometers per hour. One full lap takes 225 million years. In the time since the last dinosaurs went extinct, we haven't completed one single orbit. At the galactic center, there is a black hole 4 million times the mass of the sun. It has been mostly quiet for millions of years. But there is evidence, a faint eerie glow above and below the galaxy called the Fermi bubbles, that something violent erupted from that center between 1 and 8 million years ago. 2 enormous structures, each 25,000 light-years tall, sitting above and below the galactic core like the aftermath of something that already happened before humans existed. If Voyager 1 could somehow be aimed across the full width of the galaxy, the journey at current speed would take about 1.6 billion years. Right now, you are inside this, orbiting its center, completely unable to see it from the outside because you are embedded within its disk, surrounded by its dust. You have never left it, and you never will. Number 7. The Andromeda Galaxy, 2.537 million light-years away. Step outside on a clear autumn night in the northern hemisphere, away from city lights. Find the constellation Andromeda. Not hard, it's near the Great Square of Pegasus. Look for a faint smudge, almost looks like a cloud. That smudge is the Andromeda Galaxy, and it is the most distant object visible to the naked human eye. The light hitting your retina right now left Andromeda 2.5 million years ago. When that light started its journey, our genus didn't exist yet. Homo habilis, not even our species, just an early ancestor, was using the first stone tools. That light has been crossing empty space ever since, and it's only now landing on you, at this specific moment. Andromeda is bigger than the Milky Way. It contains over 1 trillion stars to our galaxy's 2 to 400 billion, and it is coming toward us. Right now, Andromeda is approaching at 110 kilometers per second. The 2 dark matter halos surrounding each galaxy are so large that they are probably already touching. In roughly 4.5 billion years, something happens. The exact outcome keeps getting revised. A 2025 study using precise Gaia satellite data found the collision is much less certain than previously thought. It might be a direct merger. It might be a slow orbital decay. It might even be a near miss. But in the most likely scenarios, the 2 galaxies begin to interact. No stars actually collide. Space inside a galaxy is too empty for that, but the gravitational chaos reshapes everything. Your solar system has about a 12% chance of being flung out of the merged galaxy entirely. The result, either way, eventually becomes one enormous elliptical galaxy. Astronomers have already named it Milkomeda. And here's the thing about looking at Andromeda right now. You are not seeing it as it is, you are seeing it as it was when your ancestors were making their first tools. You have absolutely no idea what it looks like today. You never will. The light from its present state won't arrive for another 2.5 million years. Number 8. The Laniakea Supercluster. 520 million light-years across. In 2014, a group of astronomers figured out that we had been writing our home address wrong. Not the street, not the city, the continent. They weren't mapping galaxies by position. They were mapping how galaxies move, the subtle tug and pull of gravity across hundreds of millions of light years. What they found was that our galaxy, and Andromeda, and thousands of other galaxies are all flowing toward the same gravitational center, like water running downhill to the same river basin. They called this basin the Laniakea Supercluster. Laniakea is Hawaiian for immeasurable heaven. The name was suggested by a Hawaiian language professor to honor Polynesian navigators who once crossed the Pacific using nothing but stars. It felt right. We had just found out how deep the ocean is. Laniakea contains 100,000 large galaxies. It stretches 520 million light-years across. Our position within it, the Milky Way, Andromeda, the entire local group, is out near the edge, like a town on the outskirts of a continent we didn't know we were on. At the gravitational center of Laniakea, there is a region called the Great Attractor. For decades, astronomers could sense its pull. Galaxies were clearly flowing towards something massive, but they couldn't see it directly because it sits behind the plane of the Milky Way, hidden by dust and gas. They could feel the gravity before they could see the source. Like detecting a current without seeing the ocean. You could fit roughly 5,900 Milky Ways across the width of Laniakea. And we didn't know we were inside it until 11 years ago. What else are we inside that we haven't named yet? Number 9, the Buddha's Void. 330 million light-years of nothing. Everything up to this point has been about things that exist. This section is about the opposite. In 1981, an astronomer named Robert Kirshner was mapping the universe in 3 dimensions, plotting galaxies by their positions in space. And in one direction, the map went blank. Not sparse, not thin, blank. A roughly spherical region 330 million light-years across, sitting about 700 million light-years away, containing almost no galaxies at all. It should contain around 2,000 galaxies based on how the rest of the universe is distributed. It contains about 60, and those 60 aren't scattered randomly. They form a faint tube running through the void, like the last remnant of walls that once separated smaller empty bubbles before they merged into one enormous one. Kirshner called it the Buddha's Void. Other astronomers immediately called it the Great Nothing. Both names are correct. Voids like this aren't unusual. What's unusual is the size. Standard cosmological models can explain voids 100 million light-years across. 330 million is harder to account for. The universe may not have had enough time since the Big Bang for this void to have formed through normal gravitational processes alone. It probably grew from smaller voids merging, soap bubbles coalescing, but the details are still debated. Here is the number. The Milky Way is 87,400 light-years wide. The Buddha's Void is 330 million. By volume, you could fit approximately 50 billion Milky Ways inside it, and it is nearly empty. Voids make up roughly 80% of the universe's total volume. The galaxies, the clusters, the superclusters, all of that structure that seemed so vast is the foam. The Buddha's Void is the ocean. Now imagine you're a civilization inside it. Every direction you look, nothing. No neighboring galaxy, no star cluster on the horizon, just dark. You might spend your entire history, however long, however advanced, and conclude that your galaxy was alone. You would have no way to know that the edge of the void, dense with galaxies, exists only a few 100 million light-years away. You would never see it in time to find out. Number 10. The edge of everything. 46.5 billion light-years. You might think the edge of the observable universe is 13.8 billion light-years away, because the universe is 13.8 billion years old, and light can only travel so far in that time. But space was expanding the whole time light was traveling. Those photons left when everything was crammed much closer together. And while they crossed the distance, the universe stretched. The matter that emitted the oldest light we can detect is now 46.5 billion light-years from Earth. That is the edge of what we can see, not the edge of what exists. The farthest individual galaxy ever confirmed sits at a distance where the light we're receiving left just 280 million years after the Big Bang. The universe was 2% of its current age. There were no heavy elements yet, no planets, no chemistry beyond hydrogen and helium. That photon has been traveling for 13.5 billion years to reach a telescope that only launched in 2021. Now here's the thing that actually ends this video. There are 2 edges of the observable universe. The first is the one we just described, 46.5 billion light-years, the particle horizon, the limit of what old light has had time to reach us from. We can still receive ancient signals from beyond this boundary in some edge cases. It's vast. But it's not the scary one. The scary one is the cosmic event horizon, currently sitting at about 16 billion light-years. That is the distance beyond which any light emitted right now, today, this second, will never reach us. Not in a billion years. Not in a trillion. Never. Dark energy is pushing space apart faster than those photons can close the gap. They will travel toward us forever and never arrive. Between 16 billion and 46.5 billion light years, there are galaxies whose ancient light is still reaching us, but whose present state we will never observe. They are already gone from our future. We can see their past. We cannot see their now. We will never see their later. In about 2 trillion years, if anything is still around to look, every galaxy outside the local group will have crossed that horizon. The night sky will be dark except for the combined remnant of the Milky Way and whatever it merged with. No evidence of the Big Bang, no evidence of expansion, no evidence of anything beyond the nearest stars. A civilization born then would look up at a quiet, dark sky and have no way of knowing the universe had once contained 2 trillion galaxies blazing in every direction. They would inherit a perfect, permanent darkness, and they would have no idea what they were missing. We happen to exist in the one window of cosmic time when the evidence is still visible. Look up.